Hello everyone, welcome back to my channel. Today we will solve third problem from the Jump Game series. Let's look at the problem statement. Given an array of non-negative integers and you are initially positioned at the start index of the array. From each index I, you can jump to either I plus array of I or I minus array of I. Check if you can reach to any index with value 0. And notice you cannot jump outside of the array at any given point of time. We will look how to solve this problem starting from the brute force solution, and we will evolve towards the optimal solution like the method we follow in our each video of problem solving. So I have taken the first test case given in the Leetcode problem, and I have also written the index values, and the starting index is given as 5. With the brute force solution, we will be following the recursion tree method, where each node will be the index. So we are starting with index 5. Now the value of at index 5 is 1. That means we can go to two indexes. One is if I'm at current my index is I, then I can go to either I plus a of I or I minus a of I, provided the value of these two values lies between 0 to the length of the array. So my starting index is 5 and the value in index 5 is 1. So I can go to either 4 or 6. Now both of them lying between the within the size of the given array. Now from 4 the value is 3. So I can go to either 1 or 7. But you see this 7 is outside the array length. So we cannot go to this index 7. From 6 I can go to two indexes. One is either 4 or 8. But again 8 is outside the array range. Then I will cancel out this index 8. From 1 I can go to -1 or 3. -1 is again is lying outside the range of the array, so cancelling out this one. From 4 I can go to 1 or 7, again cancelling out 7. From 3, see we have reached a index with value 0. So that is one thing. Let's complete the recursion tree. From 1 I can go to -1 or 3, cancelling out this -1, and again the 3 index is having value 0. So I will return true. Now let's see. A recursion tree method will take exponential time to complete, and also we have some uh, uh, repetition of cases. For example, these, right? The highlighted. Now if you think this as a tree structure, and as and when we reach any index with value of 0, we can return true. So as we have already discussed in our previous videos also, like one optimal way to jump question is again BFS, which is using queue data structure. So here we will be following that data structure. As you can see, as and when we reach any index with value 0, we will be returning true. So this way we will also get the minimum number of steps required to reach an index with value 0. So with BFS we can answer both of the questions. Now in the next slide we will be analyzing how the BFS will work, and we can get the optimal solution with BFS for this problem. So I have taken the same array again, and now let's start writing the BFS solution for the same. So we will be starting with index 5. So as you know, like we use queue data structure in BFS. So we will be maintaining a queue of integer where we will be storing the indexes. So first the queue will be having value 5. Now we will check um, the value at index 5 in the array is 1. So that means I will have two options next. One is to go to 4 index 4 and another is to go to index 6. We will check whether these two values are lying within the array range. Yes, uh, it is. Then we will be popping out this value from queue, and next we will push value index 4 and 6 in the queue. And we'll also check whether any of these indexes are having value 0. Whether index 4 is having value 0, no, it is having value 3. Similarly, index 6 is having value 2. So we have to keep on continuing the problem. So solving the problem. So next I will pop this value 4, and from 4 I can go to the value of index 4 is 3, so I can go to either 1 or 7, but 1 is lying within the range of the array, so I will push 1 into the queue, but 7 is like without outside of the array range, so we'll cancelling out this index. Now we'll check. Uh, okay, now coming to 6. From 6, I can go to either 4 or 8. Similarly, as 8 is outside of the array range, we will not push this thing index in queue, and we will push index 4 only. Similarly, we are popping out this 6 value. Now we'll check whether index 1 is having value 0. No, it is not. Then again we have to keep on solving. We will pop this thing, and we next from 1 I can go to minus 1 or 3. We are cancelling out minus 1 because its value is outside the array range, and we will be pushing value 3 here, index 3 here. Next coming to 4. From 4 I can go to 1 and 7, but cancelling out 7 because it's outside the array range, and this 1 is already visited. So yes, we have to maintain one visited array also, so that, okay, I didn't mention that part here, but yes, we have to maintain one visited array, otherwise loop some loop will go on. For example, if you have an array of all the values same, then it's like we will be keep on looping. So to avoid that thing, we will be maintaining an array of visited nodes or indices. Then in this case we should not add 4 over here, right? And also it's like from so here this step again we are not coming because we have already explored these two. Now the queue we are ending with value 3. Now we will check whether it is having value 0. Yes, it is having value 0, so we will be popping this thing and we will be returning true. Let's see one example where it's not possible to reach any index with value of 0. So I have also taken this example also from Leetcode, given test cases only. So the array is given like this with the values of 0, 3, 0, 2, 1, 2, and the starting index is given as 2. So let's start drawing the BF recursion tree or the tree whatever, and then we'll see how that is not working. So we'll do the dry run over here. So we are starting with index 0. Now sorry, index 2. Index 2 is having value 2, so we can go to value 0 or value 4, and we have checked like these two are lying within the range of the array, so we will continue. From 0 the value is 3, so we will go to two options, minus 3 and 3, but minus 3 is not possible because it's outside the range of the array, and with 4 we can go to either 2 or 6, as we are maintaining a visited array nodes in the BFS method, so we will not include this 2 again in the tree as we have already explored it, and 6 it is outside the array range, so we will be ignoring this 6 also. Now only possible way to explore further is index 3. From index 3 there are two options. One is 2 again, another one is 4 again. And as you can see, like this 2 is already been explored and 4 is already been explored here. So we will be not pushing these two values in the queue. So within the queue and all with when we are exploring each of the indices, we are also keep on checking whether the value is 0 or not. But as you can see, like while solving this problem, we at the end we have empty queue, but uh, within the loop, while we have the elements within the queue, we couldn't find any index with value 0, and the queue becomes empty. So we have come out of the loop, and we have not returned from the function block yet. So at the end of the day, that represents like we didn't find any index with value 0 in it. So at the end of the loop, or after the loop, we have to return false.
So now let's code it. So as we are using BFS, and for BFS we use queue. So here also we will be using queue data structure. So we will be using queue of integer. We are using integer type because the indices are of integer type, and we will be storing the indices only in the queue. Let's take the array size. First we will push the start index in the queue, and we will continue until my queue is empty. So my current index will be the front value of the queue, and my j will be array of I. So there are two options. I can go to either I plus j, or I can go to I minus j, right? So I will check if I plus j is less than n, then I will push this value I plus j in my queue. Similarly, here also I will check if I minus j is greater than equals to 0. I will push that value in my queue. Here I will do the queue pop operation. Now a few basic things to perform. While for each current index, I need to check if my ARRI or j, whatever, is already 0 or not. If it is so, then we can return true, right? Also, I already mentioned like we should have some concept of visited array. Now if we can maintain a separate array where we can add the visited indices, and for each time we have to traverse that array or something to or we can to identify whether the index is already visited or not, or we can use some unordered map to find in order of one time like whether some index is already visited or not. But in all of these cases we need either some extra space, or at least some extra space, order of n space, to store the visited array nodes. To optimize that thing, you can reuse this array value itself. Why? Because first thing is like we have given the reference pointer to this array, so we are allowed to change the values of the array. And one more thing is like the array is having non-negative integers, so array in each value in the array, given array, is either 0 or positive number. So we can mark them as minor. There are two options: either we can mark them as -1 or some negative number, or we can mark the value itself in the negative minus format. For example, we are doing this thing. Here we will be checking array of I is array of I into -1. For example, we are doing this thing. Okay, I'm multiplying with -1. Then the same process. So in this case, we have to check whether this I plus j, the next index which I'm targeting to explore, that is also non-negative, greater than equals to 0. otherwise it is already visited, right? So that kind of check we need to put it here, right? We will be returning 0, we are popping out, and else we will be returning false. So when we are returning false, when the queue is also empty and we haven't find any index which is having value 0, so we are returning from there, right? Now this will handle the edge cases also. For example, the edge case will be like when n value is 1. So array is given a single element. For example, that single element can be either 0 or some other number. If it is 0, then we can return true because it's a single element array and the value in the array is 0. Single element is 0. So we have to return 0. What will happen? The start is only possible value of start will be 0. So we will be pushing in 0 in the queue, and the queue is not empty, so we will be going inside the while loop, and we will be popping the value 0 from the queue, and we are checking here like, okay, fine, array of I, which is start index, which is having value 0, so we will be returning true. Now take another example where the array is not having, it's with a single element but the value is not 0. So we won't be we will be coming inside this while loop, but this part we won't be executing because this won't return true, and this array of I will be some minus value, and these values will not get executed because of the check, like it's boundary check condition, right? So what will happen? Eventually the queue becomes empty and we will be coming out of this while loop and we will be returning false. Now one few things that we have to add over here is based on when n is 0 or the start value is less than 0 or start value is greater than equals to n, then we will be returning false. I think with this we have covered all the base cases. So now let's run this thing. Okay, this is interesting. You see, we are given one error, which is some overflow is happening, right? Now, why this is happening? Let's see. All possible places where the overflow can happen, it's this kind of check, and this won't be possible, but here. Okay, so array of I, it's given, it is 5 into 10 to the power 4, that is of length. Okay, nothing is given for this thing. Okay, so as you can see, like all the positive numbers are given and we are multiplying it with -1. It might happen like array of I is the highest integer max and multiplying with -1 is given some error. So instead of this thing here, we can put it directly -1, because anytime we are checking this thing and we are not reusing that value anywhere, so we can mark it to any negative number. So now let's run this and see whether it permits or not. Okay, so this is interesting that we have solved. It's got accepted. Now let's submit this code. Okay, that has been accepted. Now we will look for the time complexity and space complexity. So the time complexity will be order of n. Why? Because we are exploring each node or each index once. So time complexity will be order of 1, and order of n, and space complexity is also order of n. If you can consider, we are using a queue, but with each queue you can say like, okay fine, we are just at one time we can go to two values only, either I plus j or I minus j. So in that sense it's kind of constant time. So yeah, and we are not using anything extra, but we are using queue. So yeah, that's the time complexity and space complexity for this problem. So thank you for watching.